Good afternoon, class. Today we will continue our topic on slope of a line. We'll talk especially about the other equation. We talked about the slope-intercept form the last time. Today we'll concentrate a little bit more on the point-slope form of the equation of a line. This equation is very important as the other one we talked about, the slope-intercept form. What this point-slope form is, it implies that the difference in the y-coordinate between 2 points on the line, that is y minus y sub 1, here we have 2 points on this line here, and the difference in the y-coordinate is our vertical change. So that's what that represents. Now that is proportional to the difference in the change of the x-coordinate, that is x minus x sub 1. So there is a proportionality here, and this proportionality constant is what we call the slope of the line. So if you look on my left hand side here, I have here this constant m is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Those subscripts are put there for convenience, because if you're using 2 points, you want to name these points. You can call it point 1 and point 2, so you use subscript. So here I'll be calling this one here. You can call it any one you want. I'm going to call this one here x sub 1, x sub 2, y sub 2, and this one down here, I will call it x sub 1, y sub 1. And those coordinates, I could use them in this formula here to find the slope of this line. This is actually, it can be termed as a rate of change. A change in y over change in x. Delta y over delta x. So you can also term it that. Now, if we take this line that we have here, this is our y and this is our x, those 2 points, and we substitute the x and the y coordinate in this formula, we'll get that slope. So let's see what the slope of this line would be. So if you do that, you'll get, let's say, our y, I will call this here y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can change them around as long as you go in the same order. There's no harm in doing that, you'll get the same value. So then here, I will have my x sub 2. My y sub 2 is 4, and my y sub 1 is minus 5. So it will be minus and negative 5 using the formula. And for the change in x, it will be x sub 2 here is 2 minus x sub 1, which is minus 1. And if we simplify this now, we'll get the slope of that line. This is going to be plus, this is plus here, and this is going to be equal to 9 over 3, and it gives us a slope of 3. So that line here, the slanted one, it has a slope of 3. Meaning to say, if you start from the lower left, and you go up, travel along that line to the upper right, you are going to be ascending. You're going up. It has a positive slope. Alright? So our main aim here is to use this formula for the point slope form of the equation of a line. This one here is the point slope. Form of the equation of a line. Now, if we know the slope, class, and we know 1 point on that line, we can write an equation for this line. And that is a good thing to do, to know how to write an equation by just knowing the slope and a point on that line. And we'll be using the point slope form of the equation of the line to do that. It's a very convenient way to do it. So let's go ahead and write the equation for this line. We know the slope, and of course by inspection we can pick out a point on that line. I'll use this point here, point x equal to 2, y equal to 4, and I'll use my slope that we find here, m equal to 3, and I will use that formula for the point slope form, and we will find an equation for this line that we have in the coordinate plane here, this one. All right, so let's go ahead and do it. Any question on what we're doing here? This is a very nice topic. It's good to know this one. So now our equation is y minus y sub 1 equal to m times x minus x sub 1. So I'll call this here my x sub 1 and this one here my y sub 1. So what I have here then by substitution, class, I have here y minus 4 is equal to 3 times x minus 2. Because my x sub 1 is 2, my y sub 1 is 4. So all that's left for us to do here then is to do some simplification, and this is going to give us y minus 4 equal to 3x minus 6, and then if we go ahead and add 4 here and add it over here also using that rule, the addition equality rule, then this here can cancel off and we get y equal to 3x, y equal to 3x minus 2. So now this is the equation of our line, of this line here. This equation here for this line is y equal to 3x minus 2. And that equation is in slope-intercept form, the type we were dealing with the last time, the equation. So there's a relationship between these equations. We can transform one into the other. And that's a convenient thing to do. Now, in this way, the slope-intercept form, we can relate that equation to that line. So what does those constants mean, the one at the back, the negative 2? If you look at this line here crosses this y-axis at this point here. That negative 2 is that point. This is what we call the y-intercept. The y-intercept for that line. So you see how convenient it is. And the slope m, this gives you the slope of this line. Remember, our delta y over delta x is our rise over run. The rise is our vertical change, and the run is our horizontal change in x. So if you start at this point on this line, and if you run 1 unit to the right, and if you rise here, remember we are at minus 5, y is minus 5, and if you rise 3 units up to negative 2, you see you're back on that line. If you run 1 more unit, let's say negative 1 is here. If you run 1 unit and you rise 2 units, you're back on the line here. Rise over run. So it's a convenient way to do it. Now, as I had mentioned to you, that this point slope form implies that the difference in the y-coordinate between the 2 points on the line, that is the y minus y sub 1, is proportional to the difference in the x-coordinate x minus x sub 1. And that constant of proportionality is our slope. All right, so make sure you're familiar with those equations and the slope. Now, let's go one step further now and solve some problem. Let's say, and you have many of these problems in your worksheet. Let's say if you want to draw now a line that is parallel to that line, another line, but one that is parallel to this one, we can use that point slope form of an equation of the line and the known point. And if we know a point where that line passes through, we can go ahead and write another equation for a line parallel to this line. So let's use this point here, where x is 0 and y is 4. This point here. X is 0, y is 4. All along the y-axis here, x is 0. But way up here, y is 4. Let's say now you want to draw a line parallel to this line, where you want to write an equation for that line. So this line here is going to be one like this. Alright? So now we have another equation here. And let's say we want to write one of them here, this one parallel to that one. We draw another equation, but we want to write an equation for that line through that point, x equal to 0, y equal to 4. Now, we can use this equation, this point slope form of the equation of the line, and write an equation for this line that's parallel to that one. So let's go ahead and do it. What we need is the slope, and we need a point. And we do have a point. But there are some facts we need to draw on. Our prior knowledge tells us that lines that are parallel have equal slopes. And if we use that knowledge, that parallel lines have equal slope, then we know that the slope for this line here would have to be, call it m sub 2 equal to 3. Alright? So that slope here has to be 3 for it to be parallel. So now we know the slope for this line, if it's parallel, and we know a point where that line passes through. So we can use the point 0, 4, and m sub 2 equal to 3, and write an equation for that line. So let's go ahead and do that then. And we'll be using our equation here, y minus y sub 1 equal to m times x minus x sub 1. And we can call this here x sub 1, this here y sub 1, substitute them into that point slope form of the equation of a line, and simplify it. So let's go ahead and find the equation for this line. As I mentioned, equation for this one here, I'll put it over here. This one here, y equal to 3x minus 2. And we know what those negative 2 and the 3 implies, that equation. So this one now, it will give us y minus 4 is equal to 3 times x minus 0. X sub 1 is 0, y sub 1 is 4. So we take those values, put them in there, and simplify. Then y minus 4 is going to be equal to 3x. 3 times 0 is 0. Y minus 4 equal to 3x. And then we add a 4 over here, and a 4 over here, and it gives us y equal to 3x plus 4. And this is the equation for this line here. Y equal to 3x plus 4 is the equation for that line. Now what does that tell us there? We can relate that equation we find here now quickly to that line. This 4 here is where the line crosses the y-axis, that's the y-intercept, and this 3 here is the same slope. This line is parallel to that one, and the equation for this one here, which is parallel to the other one, is y equal to 3x plus 4. The equation for the original line is y equal to 3x minus 2. 3x minus 2 crosses the y-axis at minus 2, this one crosses it at 4. And there you go, we use that points loop form to solve that problem. You can also use it to find lines that are perpendicular to the given line, and many other problems you can solve. So any question in class? You have several problems to solve that are of the same nature like this. So make sure that you solve those problems. Any question? Okay, so I'll let you do the work, and then we'll talk more about these later on. Thank you.